Alright guys, welcome back to another video, and today we'll be talking about sequences, and basically today we'll be talking about two main sequences, right? The first type of sequence that we'll be talking about are arithmetic sequences, and the second type of sequence that we'll be talking about is geometric sequences, right? So for arithmetic sequences, right? So arithmetic sequences. So arithmetic sequences are basically when you're adding or subtracting a number to the previous number, right? So it's like, for example, right, you have the sequence 5, 7, 9, 11, like that, right? They're adding 2 to every single number, right? And it's constant, like you add the same amount of the same number to every single term. Another example of arithmetic sequence that you could have is let's say 14 comma 12 comma 10 comma 8 comma 6, like that. You're subtracting 2 by every single term in your sequence. So that number that you add or subtract from each number to give it to the number after it, that's called the common difference, right? So common difference, and it's basically the numerical pattern, right? It's a numerical pattern or constant that results in the constant rate, right? That results in the next term, right? So yeah, and then in order to solve or like to figure out the equation for these arithmetic sequences, right? Basically, equation for the arithmetic sequence is basically if you by inputting the first number, and then you'll figure out what the second term is, like that. It's just basically an equation that you can manipulate to figure out the certain numbers and terms inside your sequence. And you'll be asked various questions about it, so you have to make sure that you really understand the arithmetic sequence formula. And so our formula is, so let me just get rid of all this. So the arithmetic sequences formula is a sub n is equal to a sub 1 plus d times n minus 1. You guys should probably write this one down. That's very important. So a sub n is equal to a sub 1 plus d times n minus 1. You guys be wondering, whoa, why are there so many different variables, right? Well, okay, let's just take a step back real quick, okay? So a sub n, right? Let's define our variables. A sub n, right? That's basically the total amount of terms, or you could say the term or number you're looking for. You are looking for, right? A sub 1, you could probably assume the first term in sequence. So for our early example, which was 5, 7, 9, like that, our a sub 1 would be 5, right? And then and then for d is your common difference, what you're adding or subtracting by from each term to get the resulting one. And then lastly, n is basically, you could say it's the nth number. Oops. N is your nth number, right? It's a sub n, right? It's a term you're looking for, the number of term that you're looking for. So like you're looking for the 5th term of the sequence, right? That's your a sub n. Your n is the exact term that you want, right? So nth term. Alright, so now that we've defined our sequence, right? Like our formula, let's take a look into a few example problems and see what they're asking for, right? So let me just, if you guys want, I'll give you guys a second to write all this down. If you guys need to, pause the video for a few seconds in order to understand every single part of the formula. Alright, I'm going to get rid of this now. So our first example, right? Say we have our sequence that is 5, 9, 13, and 17. ... Alright, so this is very important, right? Oops. If you see a ... after your last term is given, you know, right? You know that there's going to be more terms following the 17. Like our sequence is not only from 5 to 17. you know that they're following resulting terms. It basically goes on for infinity. That's what you know. So based off of this, right? We know this, and so let's create our equation, right? So a sub n, right? Well, first let's see which term do we want to find out, right? Well, we want to find out the fifth term, right? Because that's the one that's not given. You have 5, which is the first, then 9, then 13, then 17. You have 4 terms, and now you want to figure out the fifth one. You guys probably already figured this out mentally, but it's always very important to do it out in the equation, because as you start approaching harder problems, like it might give you like 3 terms in your sequence, and then it might ask you, okay, give me the 500th term, right? And then you'll be so confused, like, how am I supposed to do this? That's where you use the equation. So a sub n, right? So you're trying to find the fifth term, so you do a sub 5, right? A sub 5, which is the nth term you're figuring out, a sub 5 is equal to a sub 1, which is your first term, which is 5, plus d, which is our common difference. We're adding 4, right? So d will be 4, times n minus 1. And we already defined n as 5, right? Because that's the fifth term is what we're trying to look for. So 4 times 5 minus 1. Alright, oops. So from here, a sub 5 is equal, from here you guys all you need to do is just solve the equation. A sub 5 is equal to 5 plus 4 times 4 times 4. And then a sub 5 is equal to 4 times 4 is 16. 16 plus 5 is 21. So finally you'll get a sub 5 is equal to 21. So that was like one quick example of how to figure that out. Now let's do a little bit more harder one, right? Using the same sequence. Let's figure out what the 100th term is. Let's figure out the 200th term actually. Let's make this a little bit more interesting. So a sub 200, because that's the term we're trying to figure out, a sub 200 equals a sub 1, which is 5, plus d, which is 4, it's mainly the same thing, times n minus 1. In this case, what would be nb? It would be 200, right? Because that's the term we're trying to figure out. 200 minus 1, a sub 200 is equal to 5 plus 4 times 199. And if you guys need to, you can always use a calculator. So a sub 200 is equal to 5 plus, let's see what this is, 796, is that right? 6, 7, I think so. Alright. But even if I am wrong, guys, I think you guys understand. But anyways, a sub 200 is equal to, should be, if I did my math correct, 801, right? Let me just get a calculator out real quick. Check this. So we have 4 times 199. Yeah, that's correct. So it's 796. So you guys' final answer will be, when you have 200, your resulting answer will be 801. So that was a little bit more harder problem. Let's go into one more example, and then we'll go into geometric sequences. So in this case, our sequence gives us 2, comma, negative 5, comma, negative 12, comma, negative 19. From here, you're going to try to figure out, let's first find our equation, right? So if a sub n is equal to a sub 1, or let's say we know a sub n, right? A sub 1, that's 2. 2 plus d, which is in this case is negative 7, right? Because they're subtracting 7 by each term to get the resulting term. So negative 7 plus negative 7 times n minus 1. And that's the only thing we should leave blank, because we don't know what n is, right? Until we figure out which term we're trying to figure out. So from here, let's say we want to figure out the 48th term, right? We would do a sub n, or we should say a sub 48, is equal to 2 minus 7 times 48 minus 1, right? And that in this case is 47. So from here, a sub 48 is equal to 2 minus 47 times 7, and that's negative 329, right? So 2 minus 329, oops, 2 minus 329, a sub 48 is equal to negative 327. And so that should be your guys' final answer. So let me just check if I did this right real quick. Yes, okay. So this is your final answer, guys. And now let's move on to the next type of sequence. So the next type of sequence that we'll be talking about is geometric sequences. So it's very similar, I would say, to the first sequence I went through, which is arithmetic sequences, in that the only difference is that we see and we're going to be multiplying or dividing now, right, by one term to get to the next term. So, like, for example, say we had the sequence 5, 10, 20, 40, right? In this case, for our common difference, our common difference would be what? It would be 2, right? Because we're multiplying by 2. And if, just so you guys know, it's not, you don't really have to call it the common difference in this case of geometric sequences. That's usually what they call in arithmetic sequences. And so for this one, I would just say our multiplier, I'm just going to use that term, our multiplier would be 2, right? Because you're multiplying by 2. Say we had, in this case, let's say we had 40, 20, 10, 5, right? Now what would our common multiplier be? Would you just say you divide by 2, so you'd put a 2 for your multiplier? Wrong, actually. It would be multiplying by 1/2, right? Because that's the same thing by dividing by 2. Because you always want to make sure you're multiplying, right? But what are you multiplying the first term by to get to the second term? 1/2. So in this case, your multiplier would be 1/2. So now let's go to the equation, right? Or formula. Our formula is very similar to our arithmetic sequence formula. We have a sub n is equal to a sub 1 and then times r, and in this case you might be wondering what is r, I'll get to that in a second, to the power of n minus 1, right? R, okay, so we know a sub n, right? That's basically the term we're trying to find. A sub 1, the first term, r, right? That basically takes the place of d. R is basically our multiplier, what we're multiplying by each term to get to the next. And then the rest of the stuff you guys should know from arithmetic sequences. So let's go through an example now, right? Let's say we have the sequence 5, or change it up a bit. Let's say we had 17, 34, 51, and then let's say we did, should we do a random number? Let's just keep it with this. 68. Alright, so from here, let's make our equation. So we have a sub n, because we don't know yet what we're trying to solve for, equals 17, because that's our first term, times r, which is what? 2, guys, right? Because you're multiplying by 2 each time. So 2 to the power of n minus 1. And so let's say we're trying to solve and figure out, let's say, the 13th term, right? Then we would do a sub 13 equals, and I know, guys, you might be wondering, you're not really doing a sub 13. 13 should be under the a. But for this case, since I'm using a keyboard, it's kind of hard to represent that. Just know that that's how it's supposed to look like. So a sub 13 is equal to 17 times 2 to the power of n, which is in this case 13, minus 1. 13 minus 1 is 12. From here, a sub 13 is equal to 17 times 2 to the power of 12. And again, guys, you should probably use a calculator for this one. I know I would. So that, I think, should be 512. But let me just check my answer real quickly to make sure I did the math correctly. So 2 times 2, well, basically it's 2 to the power of 12. So that means you have 12 2's multiplying by each other. So you could have 8 times 8 times 8 times 8, right? From here, you'd have 64 times 64. And 64 times 64 would be, let's see here, 4,096. So you'd have 4,096 times 17. So let me get my calculator out real quick. So 4,096 times 17 is equal to 69,632. And so that's pretty whack. I'm pretty sure that's correct, but yeah, I'm pretty sure that's correct. If you guys want, you can later check my work, and if I did get that question wrong, make sure to let me know in the comments so I can fix that. But as of now, I think you guys get the gist of it. You really just need to figure out, let me just finish this problem real quick. 4096 is equal to a sub 13 equals, and if I did my calculation right, if I did 69,632 should be your answer. And like I said earlier, guys, if I did do this question wrong, make sure to let me know, because I wouldn't know, and then I will make sure to fix it after the video. But as of now, guys, hopefully you guys got a really good understanding of arithmetic sequences versus geometric sequences, common difference versus multipliers, and the different types of equations that you can use. And just to let you know, guys, you guys are probably going to need to memorize the equations, and so maybe make sure you guys make a flashcard of each type of sequence and write down the key points, like the equation, what each part of the equation means, right? Like a sub n, a sub 1, things like that. Because if you have the equation and you don't know what it means, then there's no point in having it. And lastly, also make sure you write down the common difference and common multipliers. But yeah, that's pretty much it, guys. Hopefully you guys understood geometric sequences and arithmetic sequences a little bit more than what you used to before. And I'll see you guys in the next video. And that would be the start of Unit 5, since this is the last of Unit 4. So yeah, thank you for watching, and I'll see you guys in the next video.